And we'll now move on to our next session, which is the first keynote. And this is on the rise of AI and automation in cybersecurity. And we have with us Mr. Sree Nagaralu, who is the Principal Group Manager, M365 Security and Compliance Division at Microsoft India. So over to you, Mr. Nagaralu, for the keynote.
Thank you, Samriddhi. Uh, Hi, everyone. I'm very happy to be in front of you as part of the SERI conference and just share my thoughts on the rise of AI in cybersecurity. I'm a data scientist and applied researcher by nature. Okay, and I have had experiences in building the search engines. Now I have recently started looking at AI in security, cybersecurity, and now this is where I'm at. Okay, so to give you a quick pulse on the kind of signals, I mean the number of signals, I mean that we are processing. I mean the challenges in the amount of traffic, I mean that we are seeing in or the World Wide Web or email or other telemetry, I mean that are there. I mean in Microsoft, I mean we are processing across like 24 trillion security signals every day across various properties. And AI used very heavily to power the predictions. I mean, if you just look at what we have done, like 31 billion identity threats have been blocked, around 30 billion emails have been blocked, email threats have been blocked. So the scale is massive. The amount of data, I mean, that we are processing is massive, and AI is helping us with finding right set of predictions and right set of models. I mean, like for us to help secure. Now, what do we envision from here? From here, I mean, we are envisioning something called artificial general security intelligence. So the way that any new signal that comes into play, I mean, automatically the model should be able to learn without even writing anything. I mean, using the security transformation models automatically. So that is the kind of general security intelligence, I mean, that we are aiming at. The next set of things, I mean, this is across the attack vectors, I mean, that we are talking about. The next thing, I mean, that we are targeting around is AI to detect data leaks and insider attacks. So it is not only the external actors, I mean, who are leaking the data or who are exfiltrating the data. I mean, there are a lot of insider threats, I mean, that we have been noticing. And then how do we really understand? How do we really use AI systems? I mean, that is another area of research and research that is happening, trying to identify the data leakages and insider attacks from a different dimension. So now we are using artificial intelligence very heavily, trying to correlate the signals across different systems and get to the state of trying to figure out the correlations. From there, now that there is a next question. I mean, like if AI is really helping, if we are relying so much on AI, I mean, like what happens when these AI systems themselves are attacked? That is the topic that I want to talk about today. So it is on adversarial machine learning. Machine learning is an artificial intelligence technique that can be used by numerous applications. So in responsible ML innovation, data scientists, developers build, train, deploy ML models to understand, protect, and control data and processes to build trusted solutions. The methods underpinning the production systems are systematically vulnerable to a new class of vulnerabilities, which we call as collectively adversarial ML. Adversaries can exploit these vulnerabilities to manipulate AI systems and alter their behavior. Eventually, I mean, why do they do it? To serve some malicious end goals, right? So now machine learning systems can themselves be attacked. Okay, how does that look like? So there are different phases in in the generation of machine learning models. So the training data exists, the algorithms exist, the process there is how to incorporate the ML systems into there and the output. So there are different. The attack vector is defined in different places. Like it could be a poisoning attack, it could be a membership inference, it could be evasion attack. or it could be model stealing. We defined, adversarial ML threat matrix. Like Microsoft worked with Meta to create that adversarial ML threat matrix, because we believe the first step in empowering security systems to defend against attacks on ML systems is to have a framework that systematically organizes the techniques employed by malicious adversaries in subverting ML systems. We hope that the security community can use the tabulated techniques and tactics to bolster their monitoring strategies around this organization's mission critical ML systems. The primary audience that we think for this is the InfoSec team. The matrix is structured like the attack framework, owing to its wide adoption among the security analyst community. This way, security analysts have a familiar framework to learn about threats, which are inherently different from traditional attacks on corporate networks. The second one, which is more important, is the attack vector that we have done. We seeded this framework with a curated set of vulnerabilities and adversary behaviors that Microsoft and Meta vetted to be effective against production ML systems, enabling security analysts to focus on realistic threats. We also incorporated a lot of learnings from Microsoft's vast experience in this space into the framework. For instance, we found that model stealing is not the end goal of the attacker, but in fact leads to more insidious model evasion. We also found that when attacking an ML system, attackers use a combination of traditional techniques like phishing and lateral movement alongside adversarial ML techniques and our intentional failure modes. We have incorporated like a lot of failure modes, intentionally in the ML, trying to see how the models can cope up when there are failures across different stages. I will just give a quick examples on the different types of attacks here. So evasion attacks. Attacker modifies this query in a way that causes a model misclassification. For example, if you are driving a self-driving car, if you're attacking a self-driving car, we can manipulate the images that are being processed to the by the ML system. For example, ignoring a stop sign. The ML system will start ignoring the stop sign, going down the lane, and it can break the rules, right? The next one is like poisoning attack. Attacker contaminates the training phase of ML systems to get the intended result. Here, the attacker wants to misclassify specific examples to cause specific actions to be taken or omitted. Now, take an example of a critical infrastructure system. If I submit something like an antivirus to a misclassification system, now the antivirus software itself will be treated as a malicious thing, and its use will be eliminated. So the system can be easily fooled out there. Then you have membership inference. Attacker can infer if a given data record was part of the model's training dataset or not. For example, in healthcare information, we can the model can be quickly reverse engineered by pushing and trying to figure out what is part of the training data. So if the model does not go through that set of the model can go the model is not if the model is vulnerable, then it is very hard it is very easy for getting the information out what has been used in the training data. Then you have model stealing, right? Attacker is able to recover the model through carefully crafted queries. For example, in a financial algorithm, through model queries, an adversary could reconstruct the potential outputs of the ML model that can be really used to put to any bad use in the first place. Okay, what are we doing to stay ahead of the curve here? So performing security assessments of production AI systems is not easy. We have surveyed around 28 organizations and 28 spanning Fortune 500 companies, governments, non-profits, and different SMBs to understand the current processes to place how the secure AI systems, how to secure AI systems. Out of which, we found 25 out of 28 businesses indicated the right tools are needed in place to secure the AI systems out. To address the growing needs of adversarial ML, Microsoft released Counterfeit. It's an open source tool to help assess risk by allowing users to attack their own AI and ML. The tool was developed out of our own need to secure our systems and vulnerabilities in the systems. The next one is like participating in the standards of addressing security of AI systems. The prevalent use of AI and ML across industry sectors and widespread mistrust and misunderstanding in the use of these technologies has led to an increased need for standards to define good practice and provide guidance to improve trust and market adoption. So the ISO and IEC organizations are developing AI standards, including defining key terminology and concepts of MI, ML, and AI, and then like risk management, government implications, data quality, and various topics related to trustworthiness. So we are participating heavily and trying to ensure that the AI risk management has a framework, and then there are certain standards, for addressing security of AI systems. With this, I say that though we are using AI systems heavily for going towards general security intelligence, I would say securing the AI systems itself is a big task. So that's it. I encourage every infosec, every security analyst, every security operator, every security researcher start looking into helping secure the AI systems. Thank you.